Sean the Math Swap Tutoring here, and in this video, we're going to talk about the Algebra 2 concept of solving rational inequalities. Make sure you like, make sure you subscribe, and let's get into it. So you see we have a problem here that we're going to work through, and I actually encourage you to pause the video and try to solve it, before you do this. But anyhow, we'll go ahead and get into it here. So it's 2x squared minus 5x minus 3 divided by x squared minus 4 is less than or equal to 0. Now, I'm also going to provide some steps, uh, for solving these so you have a systematic way of dealing with them. Okay? And so the first thing you want to do is you want to identify your critical points. So that's specifically um, where the numerator is equal to 0, and then where your denominator is equal to 0. So, and I'll also say this too, we're going to need to factor this as well, which you'll see. But specifically, where the numerator is equal to 0, that identifies basically roots, you know, roots. It's essentially where um, the whole equation goes to 0, where the graph goes to 0, so to speak. Whereas where the denominator is equal to 0, I meant to say zeros. It represents zeros of this equation or the inequality. But where the denominator is equal to 0, that represents places where this particular rational expression does not exist. Whenever a denominator goes to 0, that just represents somewhere where, like a function or whatever doesn't exist. It can't be equal. It'll never be equal at that point. Okay? So, so we're going to identify the critical points, and a lot of times we'll need to factor first. Okay? So let's factor 2x squared minus 5x minus 3. So first of all, the way we're going to do that is we want to see how can we split up this middle term in such a way that we can factor by grouping. So what I'm going to do is I'm looking at uh, negative 5 and the negative 5x. You also can kind of consider what we usually consider, which is looking at this 2 and looking at this negative 3. What what can we multiply that'll give us negative 6, which is 2 times negative 3, that'll add or subtract to give us negative 5. So that would be negative 6 and positive 1. So what I'm going to do with that information this time is I'm going to use it in this manner. So 2x squared minus 6x plus x minus 3. So I'll split up negative 5x into negative 6x and positive x. Same deal, right? And that's going to be over um, x squared minus 4, which you see that's the difference of squares. That's just x plus 2, x minus 2. Okay? Now, factoring by grouping means that we're going to group the polynomial into two different groups, and then we're going to factor out of each of those sets of parentheses. So in this first set of parentheses, we can factor out a 2x, and that becomes x minus 3. And then this next one, really there's nothing to factor out. I just put plus 1 and then times x minus 3. You'll see why I did that and why that makes stuff a little bit more clear here in a second, hopefully. Write the rest of the problem back down. Okay, and so then we factor again up top. Each of these terms, this one and this one, have an x minus 3 in them. So we're going to factor that out now. So that becomes x minus 3. And then that leaves us with 2x plus 1. X plus 2, x minus 2 is less than or equal to 0. Now let's set the numerator equal to 0. So with so when we set that equal to 0, that's just like setting both of these separately equal to 0. 2x plus 1 equals 0. And so that gives us x equals 3, and then x equals negative 1/2. So these are critical points. Now, when we set the denominator equal to 0, x minus 2, I mean plus 2 equals 0, x minus 2 equals 0. So let me actually use a different color to make these stand out here on the screen. These are our critical points. Okay. Hold on, where'd my cursor go? What happened? Okay, there it is. Sorry, I couldn't see it. Okay, so x equals negative 2, and then x equals positive 2. And again, I'm going to put some boxes around here. These are our critical points. All right, so the next step is to graph the critical points on a number line. Okay, so I'm going to draw this number line like so. Put 0 right here. Let me 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. -1, -2, -3, -4. Now let's graph these critical points. So you have x equals 3, that represents a 0. You have x equals negative 1/2, which is right here. It represents a 0. And then you have x equals negative 2, which represents a discontinuity. And then, then you have x equals positive 2, which represents a discontinuity. Okay. Now, so what we want to do is we want to, step 3, test values around each critical point to see if positive or negative. Oops, I didn't mean to write that like that. So yeah, so this is key. So you kind of have to be careful how you characterize these because you're trying to see really what makes the inequality true. So what you're gonna do is, like, for example, at x equals negative 2, you're gonna check points in this. Let me change the color now. You're gonna check points in this area, and you're gonna check points in this area as well. And then if it's positive, then that means that so you're literally plugging in x values into the original equation, and then you're gonna check and see if they're positive or negative. If they're positive, then that means if something is positive, that means it's gonna be greater than 0, which will make this not true because a positive number is not going to be less than or equal to 0. If it's negative, it's gonna make this equation true. Okay. So but really we're really testing values in all these regions. All right. So on the left side of negative 2, let's plug in like negative 3 into this equation. Actually, I'm gonna plug it into this form of the equation, the factored form, because that's a little bit easier to see. All right, so we're going to plug in negative 3. So it's going to be negative 3 minus 3 times 2 times negative 3 plus 1 over negative 3 plus 2, negative 3 minus 2. So that ends up being negative 6 times negative 3 times 2 is negative 6 plus 1, which is negative 5, over negative 3 times 2, which is negative 1. And then you have negative 3 minus 2, which is negative 5. So I'm not going to actually find a number because you can just basically see if it's positive and negative based on the signs. So a negative times negative up top, negative times negative up on the bottom, that's going to be a positive number. So this does not represent a region where the inequality is true because it wouldn't be less than or equal to zero. Okay. All right. So this next region on the right side of 2, let's plug in -1. So you have uh, -1 minus 3, and then 2 times. I'm going to do some of this without writing it because I don't have a lot of space here. So -1 minus 3 is going to be -4. 2 times -1 is -2 minus 1 is -1. That's going to be over -1 plus 2, which is 1, and then -1 minus 2, which is -3. So negative, negative, so that's 3 negatives, so that's going to be, this is going to be negative in this region. So that represents a region that would make this inequality true. All right. On the left side, the right side of -1/2, let's pick 0. 0 is an easy value. So you got 0 minus 3, which is -3. 2 times 0 plus 1, that's just going to be 1. 0 plus 2 is 2. 0 minus 2 is -2. So you got two negatives. They're going to cancel out. So that represents a positive region. So this region doesn't will not satisfy the inequality. Okay, next we're going to do between 2 and 3. Okay, so I'm talking about right here. So let's pick 2.5. So 2.5 minus 3 is going to be -1/2. Then you got 2 times 2.5. I mean 2 times 2.5. 2.5 as a fraction is 5/2. So it's gonna be I think it's gonna be 6 over 2.5 plus 2, 2.5 minus 2. So 2.5 plus 2 is just 4.5. And then 2.5 minus 2 is just 1/2. So are there any, there's one negative here, so this is going to be negative as well. Okay. And then finally, let's pick something on the right side of 3, which is right here. So let's pick 4. So 4 minus 3 is 1. 4 times 2 is 8 plus 1 is 9. 4 plus 2 is 6. 4 minus 2 is 2. So that's all positive. All right, which leads us to the last step, which is um, write the solution. And the solution is going to be a range of x values where that satisfy the inequality. So we identify the places where this is negative are the places where the inequality is true because something that's negative is going to be less than or equal to 0. Something that's positive is not going to be less than or equal to 0. So this is a good region, so to speak, and so is this one. So the answer is written as follows. Okay, so it's going to be x is going to be between, so -2, so x is greater than 2, so it has to be greater than, not greater than or equal to, because -2 was a discontinuity, a point where it doesn't exist. So x is between -2 and then let me see, 1. Okay, so it can be less than or equal to -1/2. And so we're going to do union. That means it also includes now the region between 2 and 3. So that's going to be x is so let me see, 2 was also like a discontinuity. So that's going to be x is greater than 2, but then it's going to be less than or equal to 3. Again, because 3 was a 0, so it can be equal to that. This is the final answer. Okay? So it's a few steps, but it's not that bad. So um, let's go through another example here. So you have x squared minus x minus 6 divided by x minus 1 squared is greater than or equal to 0. Okay, so let's step one, we want to identify the critical points. So we're going to factor x squared minus x minus 6. What times what is negative 6 at an add or subtract to give us negative 1? So that should be negative 3 and positive 1. So x minus 3. No, no, I mean to say 2. X plus 2. Let me make sure that works. X squared plus 2x minus 3x. Okay, that works. Over x minus 1 squared. So that's just that repeating. Okay? So set the numerator equal to 0. So x equals 3. And then x equals negative 2. So here are a couple of critical points here, specifically zeros. Okay, and so then you have um, sorry, give me a second here. Okay, so then you have where the denominator is equal to 0, x minus 1 squared equals 0, square root x minus 1 equals 0, and so x equals 1. And that represents, remember, that represents like an asymptote, like a discontinuity, whatever you want to call it. Put a box around there. Now, so we want to graph these. So I'm gonna put the 0 here. You got, I'm just gonna do 3 on each side. 1, negative 2, negative 3, 1, 2, 3. So that's a 0. Um, this is a 0, and then you have the asymptote at 1. I just put that as a O to kind of remind me that's a place where an asymptote is a place where this rational can't be equal. Okay. All right. So after we graph that, now we want to test some points. All right. So let's test negative 3, which is in this region here. All right. So I'm going to use my space a little bit more here elsewhere. So negative 3. So negative 3 minus 3 is going to be negative 6. And then negative 3 plus 2 is negative 1. And then negative 3 minus 1 is negative 4 squared is 16. This is going to be positive right here. Okay. And so now we're going to test 0, which is in between negative 2 and then the asymptote at 1. So 0 minus 3 is negative 3. 0 plus 2 is 2. 0 minus 1 is negative 1 squared is 1. So this is negative in this region. And then finally, well, not finally. So now we have between 1 and 3. So we'll test 2. 2 minus 3 is negative 1. 2 plus 2 is 4. 2 minus 1 is 1. Um, so 2 minus 1 is 1, which is squared. When squared is 1. So this is going to be negative also in this region. And finally, let's test, we'll test on this side of 3, we'll test 4. 4 minus 3 is 1. 4 plus 2 is 6. 4 minus 1 is 3 squared is 9. Okay, so that's definitely positive on that side. Okay, so now let us write the answer to this. So x. So first of all, before we do that, which regions represent areas where that solutions are that would make this inequality true? Has to be greater than or equal to 0. So that means, in other words, they have to be positive. So this region right here and this region right here. So the region on the left is going to be x is less than or equal to -2. Well, hold on, let me see what's, yeah, -2 because that was a 0. And then you also have um, x is greater than or equal to +3. Okay, let me make sure that I looked at that correctly. Yes. Okay. So these are the answers here. So not that bad. Um, just 4 pretty basic steps. Just to make sure you keep track of your negative signs. Make sure you factor correctly. Um, and don't overthink it. It's not that bad. Let me know if you got these. Watch this video as many times as you need to until you get it, and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.